Hello everyone and welcome to this video tutorial. My name is Javier Ramirez Moral and I am currently studying the multi-cloud system master at Tajamar. Today I am here to present a project I have been working on called TerraKubeSphere Part 2, Power Conversational AI Chatbot with AWS. Chatbots have emerged as one of the least trends in modern day technology, and they are taking a huge impact on our day-to-day activities. And Amazon Lex is one of the most popular platforms for creating fast and scalable chatbots. In this video tutorial, I will walk you through the process of creating a chatbot with Amazon Lex and Lambda, and how you can integrate it in your web app with responsive cards. And also, in the final of this video, we will see how to saving the chatbot answer in a Dynamo DB. So, to build a Lex chatbot, we need to search for Amazon Lex in the top of navigation bar. To create a new chatbot, click Create button. We are going to select Create a blank chatbot. And for our custom bot, we must set up a few basic options. Bot name, the language. This is the language that our chatbot will use to communicate. Timeout, how long we want Amazon Lex to retain the context, and we will leave the other file the default value. So excellent work. We have successfully create our custom chatbot. Let's go over the key fundamental components of the Lex service, which are items, utterance, and slots. So first, we explain what is items. As the name suggests, are a fundamental concept used to represent the purpose of or goal of a user input. Items can be viewed as a verb detecting what a user's intention is. So in my example, I have all these items. For example, order burger. If we click here, we can see that I defined all these parameters. For example, the name of the item. We have the utterances. Utterance are example of phrase or sentences that we might use to convey a specific meaning or request. For example, I would like to order a burger, or burger size, burger type. Here is the initial response that you can provide a message to acknowledge the user initial request. Logs are a collection of information that you prompt chatbot users to provide during a conversation with your bot. We have the burger site. You can select whatever slot that you want. Amazon provide you all these type of slots, or you can create a custom slot, as I have done and now I show you. We have the confirmation that help to clarify whether the user wants to fulfill the intent or cancel it. The fulfillment, this is to run a Lambda function that we'll see in a few minutes. You can define the response when closing the intent. So for example, we have also create a decoder, a select order, algorithm. So now, for view the slot style that I have already created, I create all these. For example, the slot of burger types. I modify the list of values used to train the machine learning model to recognize values for a slot. In the burger types, I have write bacon, cheese, chili, fried egg. Or for example, in drink types, I write soda, beer. So now we are going to integrate the chatbot with AWS Lambda. AWS Lambda is a way to write and run code without worrying about the setting up of maintaining the underlying server or computer resources. To create a new Lambda function, click Create Function button, and Lambda offers three different options. We need to name our Lambda function. We select the runtime in Python and click on the Create Function button to finish of creating an environment for our Lambda function. So we need to copy all this code from the Lambda function and paste here, save, and we need to deploy to start. I have used this Lambda code for the layer of Bedrock LLM language, which you can find also in my GitHub repository here. This AWS Lambda function handles fallback items from an Amazon Lex chatbot by querying the Bedrock cloud model to generate appropriate response. Additionally, enhance the function by adding the necessary layer with Bottle 3 version for our Bedrock Cloud LLM. That this is an advanced language model to understand and generate human text-like. You can integrate with Lambda function through a layer, which you can find also in my GitHub repository here. So now that we have successfully created our Lambda function, we need to connect it to our chatbot in order to improve its capabilities. To integrate with our chatbot, we need to activate some options. Code hooks, check this, use a lambda function to initialization and validation. We need to go to confirmation options here in advanced. We need to check also the invoke lambda functions, and we need to go to fulfillment advanced options, and we need to check this use lambda function for fulfillment. We need to build our chatbot, and then click in text in settings. We need to define the lambda function source, that the lambda function that we have already created, and the version of this lambda function that is latest. Now let's put our chatbot to text. You can use all of the utterance specified in each item to have a conversation and test the bots effectively. Now our chatbot is ready for deployment. For example, we start the conversation. Let's say hello. Hello, welcome to the burger buddy. Would you like to order a burger or a drink? Let's say, for example, first drink. Okay, soda, beer, or wine. In my case, soda. Would you like me to order your soda? Let's say yes. Order another burgers, side, or drink. Let's say burger, a burger. I would like to order a burger. What size burger would you like? This, for example, this the burger size, if you remember, is a type of slot that we created, and I show you the best burger, type of like burger cheese. You like me to order cheese from the best burger? Yes, I have placed your order. So we got it. The chatbot is running in a proper way. So if we are now say hello, and we say drink another one time, beer, and yes, and now I say side, let's say fries, and say no, the chatbot responds with bummer, stay hungry, my friend. This is a message that we define it here in the confirmation prompt to decline the response. If we decline the response, the chatbot responds to say, stay hungry, my friend. For now, we are going to integrate in the chatbot in our web app. We are going to use for this the communicate option, but before start with that, I want to show you another option. AWS already offers a simple method via one of these services that is CloudFormation. You will create an AWS CloudFormation stack that allows the deployment of the whole web application with just a few clicks. I want to clarify that if you want to do with this method, you have this official AWS page that explains you in a very well way. And you also have this official repository in GitHub. So this is the page of communicate. If we are going here to bot integration option, we need to select Amazon Lex integrate bot, and here we have all these instructions to integrate. So first we need to select Lex version 2. We need to create an IAM group and IAM user with the following roles. First we need to add our user to the group, and then if you can see here, I have these two roles that we need to integrate. Okay, after adding, click that button, create users. When we are created our user, we need to open user details, security credentials. We need to create an access key that we need to use to integrate. So create the access key. And we copy and paste these values. And the secret access key that we have here. Then we need to select the region that we deploy our chatbot, in our case, Virginia, the bot name, and the bot alias, and the default language English. So if we click save and proceed, we define the chatbot name or bot photo and finish. If we click, and now we have already our chatbot integrated. Now I create a S3 bucket where I upload all the files that I need to create my hearing properties. We need to activate, enable the edit static website hosting. Then we upload all these files that I use to develop my simple web application. Here in permission, we need to copy and paste this role to access our app. And here, if we are going to bucket and copy this route, we have here our web application. To integrate, we need to go this setting, install, and in install, we need to copy this script and integrate in our index file. And we need to copy and paste here. You can see here that our chatbot is finally integrated. If you click here in this icon, we can test our chatbot. And we will have our chatbot integrated into our page perfectly. Now we move to the next step, that is add card response to your chatbot, to our chatbot. So add a card response feature in a chatbot is typically a functionality that allows the chatbot to create and set structured message cards in response to a user query. And these message cards often contain more than just plain text. They can include images, buttons, links, and other interactive elements. And here in the first slot, for example, two slots prompts, more prompt options. And here in slot prompts, we need to add a card group. And here we are going to define the image URL. This is the image that we just uploaded a few seconds ago in our H3 bucket, and the title will say Burger Body, and the subtitle that appear in card. We will copy this. What size burger would you like? Here at a bottom, that is this the option that we can choose. For example, in this example, we need to put single, double, and triple. We need to do the same with the other two slots. When we need to select first build, and when we need to test. Now I have this Lambda function. Taking a look at the code in the Lambda handler function, I have modified the code inside, as we did with the first function at the beginning. And don't forget to put the URL on your image stored in H3 bucket. Now I will go ahead and copy the code, then jump over the Lambda and replace our existing Lambda function. And here we can see all of these cards that I created, and when we finish to configure the cards to all of our slots, we can see here. So you can see how the cards works in our chatbot, and we got it. Now that we have functioning chatbot, we can move on to saving the data this chatbot receives to a database. I will simply mention this part above as not to make the video long with a different chatbot. So at this point, we can build another chatbot, for example, this, and begin testing it out. In our application, these are the functions that will perceive the user registration answers to our Dynamo DB database. After you create your Lambda function, paste the following code into the function editor and save the function. For this demo, we are going to perceive our chatbot answer to a Dynamo DB. And the first thing we need to do is create a new table. In this example, we are going to use the phone number as a partition key. So far, so good. Everything seems to be working correctly, and we have a chatbot that we can interact with and filing in all the slots that we have configured. We persist those slots values in our Dynamo database. To summarize, building chatbots powered by Bedrock Cloud LLM with AWS Lex, Lambda, and CloudFormation, or communicate integrating them with a web app is a powerful and efficient way to increase user engagement and customer satisfaction. In addition to being able to have a summary of our chatbot data stored in Dynamo DB, you can easily create chatbots with natural language understanding, integrate them with your web apps, and automate various workflows using these AWS services. And you can easily build and deploy chatbots by following the steps outlined in this video without having to worry about the underlying infrastructure. And you can provide an end-to-end solution for building sophisticated chatbots that can improve user experience and streamline business operations. Upon this point in the video tutorial, I hope you have been useful and interesting. If you have any question or you want to propose ideas, do not hesitate to contact me, and see you in the next one. Thank you very much for watching.